Good morning, everyone. Lee pretty much said it. It's been just a totally amazing event so far. I can't believe that it's only been 1 year since the first GraphQL Summit last year. Who came last year to GraphQL Summit 1 year ago? Wow, not even that many people. So most people here are new to the Summit world. But there's already so many people using GraphQL in production and trying out new things. There's so many more learnings to share than even there were 1 year ago. So I think Lee pretty much got it. I'm here to tell you that I do think one of the main benefits of GraphQL is the fact that you can build so many great tools about it. And hopefully you'll understand why I feel that way throughout the talk. So first of all, who are we? I mean, you've seen the Apollo logo around. We've got a booth. But really, I would say that we're a team and a community that really believes in making it much easier and more straightforward to build applications overall for everybody who's trying to develop these kinds of applications. And I think one thing that's, I guess, different about us than all the other companies that have that is that we think that GraphQL is going to be one of the primary vehicles in the near future and the highest leverage way to improve that application developer experience for people. Right? There's a lot of other types of things you could focus on. You could focus on view layers like React or databases. But right there in the API layer, we think there's a whole ton of value that has yet to be unlocked. So why GraphQL? Why that particular technology and why APIs? And I think there are pretty much three things that stand out to me as the most important parts of GraphQL that make it a technology worth adopting over a lot of other similar technologies. The first thing is that it has a wonderful language, and this is the first thing people see when they think of GraphQL. I guess it's the name. The name has query language in it. It's a great language for declaring data requirements for your application, which is totally decoupled from where that data is coming from, how it's fetched, what happens to it afterwards. It's just a very abstract way to say, I would like to have this data, please. On the other hand, there's an equally powerful abstraction on the other side that lets the server or GraphQL API describe what data is available to the consumer, which is also decoupled both from how that data is fetched and where it lives in the backend. And then, partially because the first two things enable it, and partially, I think, because the community is just so great and people have gotten so excited and banded together, there's a completely overwhelming ecosystem of tools. There are literally thousands of tools on GitHub, NPM, other package managers. So you can now integrate GraphQL with pretty much anything imaginable that you might be using, whether it's a front-end technology, your editor, your database, or any other kind of thing. And there's one thing in particular that I want to focus on here. And if you guys are familiar with React, you might have heard this kind of slogan before, which is it's important to couple together things that are inherently coupled and decouple things that shouldn't be coupled. And one common accident people make is coupling together things that just seem to be in a similar location. For example, if you write your API with endpoints and your server is in control of the shape of the data that's returned, that might be because, well, the backend is where you do data stuff, and so that's where we put those things. But I think a really big part of the power of GraphQL is that it takes those data requirements, which are actually coupled to how the client works, and it lets the client code base specify those requirements. So instead of having this tightly coupled thing across the wire, which is the client and the data requirements it has, the coupling across the wire is much looser because it's just between those requirements and the availability of that data. You can almost think of it as a component-like approach to data, which fits really nicely, and that's why a lot of us use technologies like React or other technologies like Vue or Angular that support UI components to work with GraphQL. So basically, I would claim that GraphQL is all about providing the correct split of responsibilities between the front ends and the back end parts of your app. So it's no secret that today's apps can be quite complicated. There's a whole wealth of different front-end technologies, back-end technologies. Every company now has to have like at least 3 apps, two mobile apps and a website, sometimes iPads, sometimes Internet of Things stuff. Your backends are also getting more and more diverse. And maybe as your company grows, you've got different teams that need to coordinate between each other. So why does GraphQL and Apollo, why do they help with that question? I think it's because they make the picture look something like this. They live in the middle between all of your front ends and all of your back ends and fill in something that nobody really had their eye on up until that point. Because from the back end perspective, the responsibility is to provide the data. And from the front end's perspective, you're consuming it. But For the first time, GraphQL enables a whole world of tools to live in between and deal with actually how that data gets from point A to point B, which it turns out can be a lot more powerful and also complicated than people might have thought, especially because client-side rendering apps, especially in the web context, is a pretty new thing. So where are we today with that? Apollo and GraphQL in 2017 is pretty sweet. Like you guys heard yesterday morning, James announced Apollo Client 2.0, and has a lot of cool features, but the really most exciting thing to me is that people in the community have already jumped on top of that release even before it was out and started building those exciting new features into their integrations for Angular and Vue. So we maintain the React one, but there's now great real-time updates and server-side rendering for Vue and for Angular that take advantage of the new flexibility of that platform to tie nicely into those ecosystems, which I think is really, really cool to see. And on the server, it's now easier than ever before to write a GraphQL server in pretty much any programming language you want. I think when GraphQL was first introduced, people's main complaint was, I don't really know how to get started writing a server. But today there are so many tutorials, so many libraries for every single language that that's not really an excuse anymore. You might now have the question, how do I take my server into production? But getting a GraphQL query running against your data isn't the problem that it once was. As you have heard even in some talks yesterday, people suggest the first step is building that proof of concept on top of your data. So essentially, there's this duality, which is really important, of the client and the server, where the client knows about the data requirements and they're detailed and fine-grained, and the server is flexible and performant and provides those capabilities. So the second concept I want to introduce that is really important to me is that a GraphQL query is a really nice semantic unit of data fetching. And what does that mean? I guess it means to me that you now, maybe for the first time, have the ability to encode all the data you need for one part of your user interface in a single place, which is one query. Because the language is often flexible enough that you don't need those multiple queries to make that happen. And from the server's perspective, that's immensely valuable, because now what happens is your server gets all that information in one go as well. You no longer have to send a bunch of separate endpoint requests. You can tell exactly where that query is coming from and exactly what is needed. So for example, in GraphQL, it's really easy to do something like avoid having multiple backend fetches happen for the same data. Because if you're rendering a list of comments and you're getting an author for each comment and they're very overlapping because maybe it's a conversation, it's pretty easy in GraphQL today to make sure you only fetch one of those authors once. But if you were individually loading those through separate endpoints, it would be really hard to predict if you were about to fetch the same data or different data. You would probably have to have some caching across those requests or build a special endpoint. So knowing the data that you want entirely ahead of time makes it very efficient. So I want to orient my talk today around some of the main questions that we hear from people who are productionizing GraphQL today. So it's easy to get started, set up a simple client, a simple server in any language, but then people end up with some questions of this form, and these are the ones I want to focus on. How do I have less resources to load my data by caching? Caching is probably the #1 thing that everyone asks about. The second thing is, how do I understand what's going on? How do you make your server and your client not feel like a black box where you don't know what is happening there? And the third one is, how do I make my GraphQL more modular? I heard that I should have microservices, and that's been great because I've decoupled all my stuff and I can deploy it separately. But now you're telling me to go back to that world where everything's in one place again, and I'm not entirely comfortable with that. So let's get into it. So let's talk about caching. This is a silly question. How many people feel like they should be caching their API? OK, it's like most people. It's very relatable talk. So it turns out that when you step into the world of GraphQL, you have to take a little bit of a different approach because there's some small questions like, OK, sometimes HTTP caching doesn't support post requests, and sometimes you send queries with post requests. That's like a pretty minor thing. They could probably just fix that. Then some larger problems, like maybe you have a greater diversity of requests. Because you have more different queries that you might be sending, maybe it's harder to predict and make that query match up with your cache. And then one thing that's also really interesting to me is that GraphQL itself is transport independent. But things like HTTP caching are very dependent on that transport. So if you were using HTTP and then suddenly you wanted to switch to using WebSockets or something else to fetch your GraphQL data, then none of your caching setup would work anymore, which would be kind of a bummer because there are different trade-offs for different kinds of transports, especially like binary transports for mobile devices or something like that. But it's not all bad news because there's a whole bunch of benefits you can get from GraphQL that you couldn't get in the endpoint-based world at all. For example, because GraphQL has this fine-grained nature of defining the backend, you can define your cache control in the same way. And perhaps you could declare that caching information alongside your schema and resolvers rather than having to worry about it separately for each query. So just as a background, one of the things that I think is a pretty common way to do caching in REST or HTTP APIs is to use a cache control header and pass something like max age. So you say, my unit of data is this endpoint, and here's how long I want it to live inside my caching infrastructure. That works pretty well. So let's go with a couple of ideas for how we might want to do caching in GraphQL. So the first, most obvious question is, should I be doing this caching inside the server? And you might have heard about Data Loader, which is kind of like a caching solution. It's primarily designed for caching inside a single request. If you do multiple fetches to your backend inside one query, it can deduplicate those very nicely. But it might get a little bit more complicated if you want to do it across requests. Like if you have a public-facing website and you don't want it to hit the backend every time you go to the homepage. And additionally, you probably don't want to add any complexity to your GraphQL server either, because you want to look inside there and you want to see a nice, clean translation layer between your front and your backends. You don't want to inherit a whole bunch of custom caching code and logic. So my feeling is that caching doesn't belong inside your GraphQL API. And I think that's something that you might hear from other people as well, is probably you want to do it either above or underneath your GraphQL API. Either you're caching the results of that server, or you're caching the requests to the backend. And that lets you keep the complexity out of those resolvers. And similar to HTTP infrastructure, which I think is probably a good sign, you have a separate layer that is doing that caching. OK, so to me, what this suggests is there needs to be something like a caching layer that supports GraphQL. It supports some of those problems that we were talking about, like post requests, fine-grained TTLs, stuff like that. And we also need somewhere to put all that complexity that we just said we want to remove from our GraphQL server. So today, one of the first things I want to introduce is the concept of a GraphQL gateway. So you heard Johannes talking yesterday about the idea of building a microservice with GraphQL from the start. And this idea is complementary to that. It's the idea of passing your GraphQL requests through a layer that handles your infrastructure concerns for you so that you don't have to worry about those being inside the server. And you might ask, where might I get a GraphQL gateway? And this is the part where I introduce Apollo Engine. And Apollo Engine is a product that we announced this week, which is the first ever GraphQL-specific gateway technology. It's an infrastructure component that sits in between your clients and your GraphQL servers and does stuff like caching, tracing, and errors. If you've used Apollo Optics, it's the next version of that, and it has all those same features plus more. So now, when I'm talking about the gateway component, I'll refer to some of the things that Engine does, but also a lot of things that it doesn't do yet. And this is a component that you could build yourself, or there might be other people who start building these things as GraphQL becomes more and more popular. But I'm definitely very convinced that this component needs to exist. OK, so let's look at GraphQL result caching in this context. So the same way that the server provides the data capabilities in a fine-grained and flexible way, I think the server should also provide that cache control information in the same flexible way. And then, when you get to the gateway, it can read those cache controls and do that caching the same way that it would with those HTTP APIs. And that means you no longer have to have that complicated stuff inside every single server. It can live inside that gateway layer, which can be implemented once. And then on the back end, you can use Ruby, you can use Scala, you can use JavaScript, Python, anything you want. And it's not dependent on what features that particular library has for you. So that could actually be a good approach, even if you're building your own infrastructure, is to figure out how to decouple yourself from a particular implementation. So the next thing that I think is really cool is that it's not just a server-side thing, right? Because probably a lot of you are using something like Apollo Client or Relay, which might not feel like it, but is another cache. Actually, there's caches all the way up and down everywhere in your life. And so if you already have, it's true, we found some caches in between Apollo Client and the React component. So there's like 3 more caches in that layer as well. I don't know how we became a caching company. I'll have to look into that. So if you're already using these cache controls to explain how data should be cached in your API layer, why not use the exact same cache controls to explain how data should be handled in the client layer? And the best part is that GraphQL is the same language all the way through. It's the language that you put inside your components. It's the language that gets sent over the network. It's the language that gets sent past the gateway. Everything is GraphQL, so these concepts are available to you all the way through. So how are we going to accomplish this? And it turns out the GraphQL specification has an answer for us. And the answer is that the GraphQL spec has a feature called extensions, which means that you can have the entire GraphQL specification of specifying the query and getting the results in the exact shape that you expect. But then, if your server wants to, it can provide an additional field next to the data and errors called extensions. And the client can safely ignore that if it doesn't understand what they mean. You can turn them on and off if you want. But it lets you add additional data to that response. And so one of the things that makes all this possible, this caching feature inside a GraphQL gateway and inside Engine, is the idea of a standardized way to do cache control for GraphQL. So this is kind of a new thing, the Apollo cache control standard. You guys can check it out on GitHub, and I'll show you in a second how it works. But the idea is, wouldn't it be cool if every GraphQL server had a standardized way to expose information about caching? So anybody who's building a GraphQL client, anybody who wants to build their own API gateway for GraphQL, can take advantage of that data, and then all the GraphQL server implementers have to do is provide that information as part of the result, and then they don't have to worry about what happens after that. So it decouples the idea of building that complicated caching infrastructure from what the GraphQL server library implementers might want to be spending their time on, which is probably making it easier and better to build a GraphQL server. So it's pretty simple. I think the best thing about this spec is it's exactly what you would have come up with if you did it yourself, which is you take the max age that I was just talking about from REST, and you put it on the field, and then you're basically done. So it's in the extensions. It's got the path to the part of the result. It's got that max age, and now all your proxy or gateway has to do is interpret that data. And the other really cool thing is we also have an initial JavaScript implementation of how that might work in a GraphQL server. So if you're writing your server with JavaScript, you can right now try out using this cache control JavaScript package that lets you specify cache control information on your types, then also on fields, and even dynamically inside your resolvers. So all the different ways that you can use GraphQL on the server, you can now add the caching directly there alongside the rest of your code. So for example, you could even pass through the caching information from your underlying service. So essentially, this is another instance for me of that idea of that things should be coupled in the right place, right? Your GraphQL server is a thing that knows about how those backends work, and your resolvers are the place where that data is actually called. So that's where it should happen. That's where you should be doing your cache controlling, not on some layer that's outside of it. So the server should be in charge of defining what the caching is like, but at the same time, the client should be in charge of figuring out what data it wants. And then those two are combined to figure out how that actual response is cached, and it depends both on the capabilities exposed by the server and on the request made by the client. So this, to me, feels like a really GraphQL-focused way to do things. So I think the first core idea for me here is that as a community, in order to make things like caching work seamlessly between different kinds of tools, we can take advantage of GraphQL's existing advantages and figure out how to apply the same advantages that we already have, but to other concepts. So not just getting the fields and returning the data, but getting the fields from the query and returning cache control information, for example. And again, the other really exciting thing to me is that it's a full stack approach. Because GraphQL is that thing that lives all the way between way back in the back end, and then it goes all the way up to your actual UI components, this thing isn't just a one-time use thing that you use for that gateway part of your architecture. It's something that you can use everywhere. So if we actually get it right as a community, if we get all the feedback together and figure out the right way to specify when GraphQL data should expire, maybe you won't have to write so many refetches or manual polling inside your GraphQL client anymore. And it'll all work together pretty seamlessly. All right, so now I want to move into a second example out of the three and basically apply the exact same concepts that I just said, but this time to another thing. So it's very good parallelism. So tracing errors is all about getting information from your server. The thing on the left is bad, and the thing on the right is good. And on the left, you see very coarse-grained, not detailed information. On the right, you see very detailed information that gives you a lot of useful tips. So you probably want the thing on the right. And that means that something that only tracks performance information on a per endpoint basis is probably not going to work very well. And to be clear, there are a lot of tools that will give you something like per endpoint information for GraphQL servers, because at the end of the day, those are just functions. So you just have to instrument the functions, and you've got your information. And I would say, if I was the product manager, product marketer for GraphQL, I could say GraphQL is the first API technology with fine-grained insights and analytics built in. And when I say GraphQL, I actually mean GraphQL, not like Engine or some other tool that does this thing. Because this would actually be completely impossible without GraphQL. Because you've got to have the schema, because otherwise you don't have a UI to display this. You don't know what fields exist. And you've got to have the query language, because if you don't know what fields those clients are using, then you don't know what fields the clients are using. If you just get an endpoint and that returns 1,000 fields, it's pretty hard to have a display showing how often those fields are consumed. So I think this is a core benefit of GraphQL, is that the server understands what fields are being used by the client and where. And putting that together with the performance information aspect, now you can move basically between information about your client and information about your server at will. So if you know that a particular resolver in your server is slow, all you have to do is find the queries in your client that use that resolver, and you've found where the performance problems are going to cause UI performance problems. So now, as a backend developer, you can understand what part of the UI you can improve with your performance improvements. And as a front-end developer, you can know where those problems are coming from. And for front-end developers, there's a particularly great advantage, which is that information for the first time is actually actionable. Because before, if you would call an endpoint and the endpoint is slow, well, then you just file a ticket and go home. But now it's not that easy. Now, what you can actually do is be empowered to change the way that your API performs based on information about perhaps what fields in it are slow. So let's say you're getting an activity feed and you have a count and you have the individual activities, and for some reason the total count is very slow. Maybe it's not critical for you to get that on the first render. And so you can actually pop that field out of your query, or if your system supports defer, put a defer directive on it, and then you can actually get the initial data much faster, and you should still tell the backend people that they should make it faster, but you can continue on your work and keep making your stuff better without being blocked, which I think is like a core GraphQL thing to do. OK, so looking through this lens before, we have this infrastructure here. We're doing the caching. We've got the server and the client. What about stuff like performance tracing? And all these items have a role in that as well. So the client's job is to declare the mapping from GraphQL queries to your UI components. If you didn't have a GraphQL client like Relay or like Apollo, it's pretty hard to achieve that declarative situation where your GraphQL queries live right next to your UI components and still keep your life to be pretty efficient, because you might end up doing a lot more fetches if you don't have that client part. So I think it actually does enable that aspect of it. The server has this fine-grained way to call backends and a natural place to collect that performance information, which is those resolvers. And then those things come together in the middle, where you can have a system that combines the knowledge about those queries from the UI and the traces from the fields in the server, and can do the complicated stuff like extracting those metrics, aggregating them, sampling stuff, and doing all the analysis that you wouldn't want to live inside your JavaScript process, for example, or your Ruby process. And if you look at some tracing standards, like the platform, I think it's called Jaeger from Uber, they have a similar architecture where there's an agent that lives outside of your server process that does all the data collection and aggregation, because you don't want that to be blocking your requests. And so another nice thing about this is that if you're going by the previous section that I had, where that's where the caching lives, you now have one place where you're doing both your caching and your performance analysis. So now maybe you can correlate. When I'm caching, is it actually faster? I hope so. How much is my cache being hit, and how does that correlate with my backend performance? How having those things in the same layer, and it doesn't matter necessarily if they're even the same tool or two different tools, makes it so that you can use those things together much more easily. And again, this time with more history, we've created a specification a couple of months ago called Apollo Tracing. My colleague Martin designed this. And the really cool thing about it is it's a way to get performance data on a per resolver level from any GraphQL server. And this time, it's actually something you can use today. So if you're using JavaScript, or Scala, or Java, or Ruby, or Elixir for your server, you can actually install a package today, run a GraphQL query, and see timing data in those resolvers like right now on your computer. And it doesn't require any services, anything. You can just run that query from GraphQL, and you can right away see what stuff is fast and what's slow. And that's something that I think creates a whole new opportunity for a whole world of tools to integrate. So now you have all this information. And again, it's tied to those core GraphQL concepts, like a GraphQL query in your GraphQL schema. So you can imagine in your editor, when you're writing GraphQL query, seeing those performance traces alongside the fields that you're writing. Or when you're writing your schema, having that have a link to where you have information about how fast that resolver performs. Or maybe when you're doing design inside Sketch, which is something you can now do with GraphQL, maybe inside Sketch it tells you, designer, look, you might want this design, but right now it's not going to work out too well. And basically you can short circuit entire parts of your design and deployment process because you have these core primitives of the schema and the query that you can attach this information to. So that's the other idea here, is because all this information that you know about your API is attached to those core concepts in GraphQL, I believe that it is GraphQL itself which enables this type of integration. Because in other types of APIs, there just aren't defined enough concepts to have that information be both provided or even received in a standardized fashion. So I think this is absolutely amazing. And I've created here a totally for free mock-up. You can use this without any sort of attribution. But you could definitely, if you take the Friday off after Summit, you're too tired because you just heard too much awesome GraphQL stuff, check out that tracing standard, install it in your server, run a query, and then just write a very simple React component that just goes right into GraphQL and displays those little trace bars for you. And then everyone on your team and everyone in the world will be able to run those queries and get a nice visual display of how fast they were anytime. I mean, that sounds cool. So I got pretty far in the design, right? But there are maybe improvements to be made. But I will 100% use this tool immediately. But unfortunately, I didn't have time to build it yet. So I think it's really cool that the GraphQL specification is robust enough to spawn these thousands of companion tools that work with every single platform in the world. Whenever somebody comes to me and they're like, can I use GraphQL? I basically never have to say no. So I think that is one of the core benefits of the whole technology. And so we already see people doing stuff like coming up with platform-specific or tool-specific ways to do things like extract performance information. Right? There are already some GraphQL servers that have their own libraries that have a very specific format. And what we've tried to do with Apollo Tracing is we actually had our own specific format that was working for us. And we decided to move in the direction of having it not be that thing so that now people can build tools like that view in GraphQL. Because the most important thing is that we don't have a whole ton of different standards for this stuff. It's important that when you have a tool that works with GraphQL, it works with as much of GraphQL as possible. Later that will include stuff like subscriptions, which is going to raise new challenges of how do you get all these tools to work together without an arduous amount of configuration. All right, so the third example, and this one is very close to my heart, is the idea of schema stitching. And you guys, I was going to ask if people have heard of this before, but if you were here yesterday, you heard about it at least 3 times throughout different talks, which is really, really cool because I can see that it's becoming a thing that's really catching on in a lot of people's minds, and that's exciting. And I think this is another instance of that responsibilities movement that I was thinking about. And I think this one is maybe a little bit less important because there isn't as much of a problem of like different versions of clients and servers. But there's still a case where you have your backend data service, which functionally has some sort of schema. It might even be written in a type-safe language. But then, when you're using today's technologies to write a GraphQL API, you often have to describe that again. And describing it again is actually a good idea, because you want to think about what your client-side API looks like. It shouldn't necessarily be tied to what the API of your backend looks like. In fact, it probably shouldn't be. However, I still want to make the claim that you're probably more equipped to describe that API for that portion of your backend closer to where it lives. Or at the very least, you might be in an organization where people own different parts of the data. So you might have a team that deals with user data or payments data, and those people know a lot more about that data model than somebody who might be on a separate API team. But basically, we've seen this pattern over and over again, which is why I'm really excited about schema stitching, is because I really think that it's a good idea to have exactly one GraphQL client in your app, and it's good to have exactly one GraphQL schema that you're querying so you can get all of your data. But we've heard of a lot of people using multiple clients together with multiple servers in the same app. And so I hope that we can live soon in a world where something like this is possible, where you can have exactly one GraphQL client and one global schema that describes the world of data that you've got in your company. And then that might be split up into multiple servers, but that's OK, because to me, from the API perspective, that's more of an implementation detail. So this is my favorite schema stitching example that I have used a couple of times. But basically, we use a ticketing system called Universe for GraphQL Summit. And thankfully, Universe has a public GraphQL API. And you can send it a query like the one in the top right, where you give it the event ID for GraphQL Summit. You can get the name of the event and the name of the city that it's in, which is San Francisco. And then a great community member named Matt Dionis, I don't know if he's in this room, he probably is somewhere, created a great API that lets you get the weather based on the name of the location. And then you're like, well, a very critical thing for me to do is to understand what weather it's going to be when I show up to GraphQL Summit. And thankfully, with schema stitching, you can actually combine these two queries so that you can pipe that city name directly into the argument of that location field and get exactly one schema that tells you information about the event and about the weather. And this is my NASCAR slide here of just how exciting it is that so many people are looking into this type of technology and type of API construction. This is a screenshot from Johannes' talk yesterday about using GraphQL schema stitching. Jason from IBM had a different way of modularizing schemas, which is also very cool. The APIs Guru guys here made a tool called GraphQL.join, which you can click on the link on when you download the slides later. We've got a library that does it. I think this is going to be a big deal. So I don't know exactly the right way yet that this is going to work, but I think making GraphQL schemas modular and then combining them, you should write that in your top trends for late 2017 in GraphQL. So essentially, the hope here is you can get the best of both worlds. You can get that developer experience of having a universal API for your front ends, but you can still have those modular and independently deployed services that you want from a microservice style architecture. And that means you're serving well both the front-end developers and API consumers and the people who are building and deploying those backends. So this is what your architecture might look like today if you're using GraphQL, which is really awesome, by the way. I'm not in any way advocating that people should start changing their APIs. If this architecture works for you, that's 100% awesome. This is all coming from a place of people coming to me and asking me, could I have a different type of architecture? And this is the same one that we use. This is the one that Facebook uses, and they sure have a lot of data in there. So it works great. However, if you're looking for that approach where you can deploy your different GraphQL services separately, you could go with something like this, where you start adding GraphQL to your backend services. So your backend services speak GraphQL, your server speaks GraphQL, your gateway speaks GraphQL, your client speaks GraphQL. Maybe your client can even use GraphQL to load data from client-side data. So now you have GraphQL everywhere, and it's all working together, and it has a unified schema, and it's wonderful. You still have a single code base, though, which is this server thing, which is, has code to stitch all these schemas together. And so the ideal picture for me is a picture that actually looks like this. Because you already have this gateway place where you're doing the caching, you're maybe doing some performance analysis using those various standards. And all that stuff would be great if it also tied into your various sub-schemas that you have. Because maybe you want to cache the requests to those backends separately, or maybe you want to get finer-grained performance tracing that shows you which backend each field came from. You want to aggregate the errors in a certain way. You can load data from GraphQL and from Neo4j and from your custom backend or legacy backend all at the same time, but still present that as a unified API to your consumers. And again, this can be especially useful if you're in a world where you're in an enterprise situation with a lot of different teams that have to work somewhat independently, and you don't want to be blocked on somebody reviewing your PRs to some schema that they own. So I think this is going to be a really huge deal for companies that need that kind of flexibility in their deployment. So the overarching point for me is that I think this duality of the client query sending the detailed data requirements, and detailed is important because the fact that you specify every field that you're looking for is a critical aspect of GraphQL that can't be overlooked. And the fact that the server schema is both flexible and very performant is like the core idea of GraphQL, and I hope that I've convinced you that all the ideas that I was covering before fit into this paradigm. And all these things are going to be continuously improving. All these three topics that we came back to. So for example, we might have some of these categories with maybe particular instances of those things. These are the ones that I had a hand in building, so those are the ones I put, but there's other options for all of these. And then here are some of these different capabilities you might have. And I want to live in a world where this grid is completely filled out with green check marks. I can look at caching information in my editor. I can look at errors in my dev tools. Actually, you can already do that, so I should have put a check mark there. There's schema stitching on the client in a sense, because you can combine your client-side data with your server-side data that came from GraphQL. So I put a little party popper on there because that was just announced recently. I think both Relay Modern and Apollo Client now have the capability to do that. Extremely exciting. So then we can come up with the next thing. Once we have all these things fully integrated, and you can just keep thinking of GraphQL as this unified and compatible way to do that middle part of your app that lives in between your clients and your backends. And I think that's why GraphQL, sometimes I think in the past especially, we would talk to people and they'd be like, yeah, it's a curiosity. It's a cool way to do some APIs. I went to a API academics conference and they compared it to a lot of other things, and there were a lot of trade-offs. But I think that's all details, because when we talk to people who are using GraphQL, they see it as something that changes the whole game of how they're developing their application. And I think we're just at the start of that. It's only been, 2 years? Something like that, a little bit over 2 years. Think about what we're going to be doing 10 years from now. And I think it's going to be very, very exciting. And I can't wait to go there with you. That's what we're all about at Apollo. Coming back to that is we got into the GraphQL hype train pretty early because we felt that it was going to be that transformative technology that was going to be a critical part of what everyone is doing. And you would really be hampering yourself if you weren't using GraphQL, especially now, years in the future. So anyway, thank you so much for coming, listening to me, and let's go on this journey together. And thank you very much.